Today's lesson is on finding inverses of rational expressions. A rational expression is nothing more than a fraction with polynomials in either the numerator or denominator. So there's a four-step method in order to find these, and I'll just get started with a specific example. I think that's the best way to show you how to do these. First of all, let's just start with f of x equal 3x plus 2 over x minus 1. Or in other words, when we're given this, what I do is I take the f of x out of there and I replace it with y. So if I want to get the inverse, I switch x and y and it becomes x equals 3y plus 2 over y minus 1. So the first step we're going to take is I like to put a 1 underneath the x, and then I cross multiply. And when you cross multiply, you get x times y minus 1 is equal to 3y plus 2 times 1. The second thing you're going to do is you're going to distribute. So this becomes xy minus x is equal to 3y plus 2. The third thing you're going to do is you're going to get all the terms with y's in them on the left and the terms without the y's on the right. Because we're going to be solving for y. So in this example, we're going to move the 3y over by subtraction, and we're going to move this x term over to the right by addition. So this becomes xy minus 3y is equal to x plus 2. The next thing we're going to do is we're going to factor out the y and then solve for y with division. So this becomes y times x minus 3, when you get the GCF of y out of there, is equal to x plus 2. And then to solve for y, you're going to just divide both sides by x minus 3 to cancel those x minus 3's out. So there's your inverse, x plus 2 over x minus 3, and we'll just mark that as f inverse of x. The hardest thing about these is to prove that f and f inverse are actually inverses of each other, to prove that we're right with this inverse. So we're going to do the proof, and the proof means I'm going to get f of f inverse of x. So starting with my original problem, 3x plus 2 over x minus 1, I'm going to substitute those two x's with the whole inverse function, x plus 2 over x minus 3. So that becomes 3 times x plus 2 over x minus 3 plus 2 all over x minus 1 will become x plus 2 over x minus 3 minus 1. And to simplify this complex fraction, we find the LCD. Amongst all the terms, the LCD is x minus 3. So we're going to multiply everything by x minus 3. So this term, this term, this term, and this term all get multiplied by x minus 3. And what that does is it cancels out these denominators, and all we have to do is distribute the 3 through these parentheses and distribute the 2 through these parentheses, and we get 3x plus 6 plus 2x minus 6 all over x plus 2 minus x minus a negative 3 is plus 3. So 3x plus 2x is 5x when you combine those like terms. And 6 minus 6 is 0. And on the bottom, we have x minus x is 0. 2 plus 3 is 5. So that simplifies down to 5x over 5. And 5x over 5, you can cancel the 5's and you're left with x. So that's the first half of the proof. The second half of the proof is to show that f inverse of f of x is also equal to x. So now we're going to take the inverse that we found, x plus 2 over x minus 3, and we're going to substitute those two x values with the original function, 3x plus 2 over x minus 1, here and here. So this becomes 3x plus 2 over x minus 1, the original function, plus 2 all over 3x plus 2 over x minus 1 minus 3. And this LCD is x minus 1. So we're going to multiply all parts by x minus 1. X minus 1, x minus 1, x minus 1. And what that does is cancels out these denominators, cancels out those denominators, and we're left with 3x plus 2 plus, distributing the 2, 2x minus 2. And on the bottom, we're left with 3x plus 2. And this negative 3 distributes and becomes negative 3 plus 3. Or negative 3x plus 3, sorry. So to simplify the top, you have 2 minus 2 is 0. 3x plus 2x is 5x. And then on the bottom, you have 3x minus 3x, which is 0. 2 plus 3 is 5. And again, 5x over 5 is equal to x. And that's the second half of the proof. So we'll go through one more of these. It won't be that much different, but it's just a second example. So this is just an example number 2. Let's have f of x be equal to 4x plus 3 over 2x plus 5. And to find the inverse, the first thing you're going to do is switch x and y. So I'm just going to mark this as the inverse. X is equal to 4y plus 3 over 2y plus 5. Step 1 says to multiply, cross multiply, and you get x times 2y plus 5 is equal to 4y plus 3 times 1. The next thing you're going to do is distribute the x. 2xy plus 5x is equal to 4y plus 3. You might want to try working this out by yourself and stopping the video and then seeing if your answer matches mine at the end. The next thing we're going to do is move the 5x over to the left and the 4y over to the right by subtraction. So we get 2xy minus 4y is equal to negative 5x plus 3. Then we factor out a y and you're left with y times 2x minus 4 equals negative 5x plus 3. And then when you divide both sides by 2x minus 4, you get negative 5x plus 3 all over 2x minus 4, and that's the inverse. And to prove that they're inverses, you're going to do f of f inverse. So you go up to the original f function and take the x's out and replace it with this inverse function. So f of f inverse and I'll continue this in a minute. So to continue where I left off on f of f inverse of x, 4x plus 3 all over 2x plus 5, but the x is really the inverse, negative 5x plus 3 over 2x minus 4 plus 5. So what we're going to do is simplify this complex fraction. The LCD is equal to 2x minus 4. So we're going to multiply this by 2x minus 4, the 3 by 2x minus 4, this by 2x minus 4, and the 5 by 2x minus 4, and see what we get. Distributing the 4 through the negative 5x plus 3, we get negative 20x plus 12 plus 3 times 2x plus 4 is 6x minus 12. And in the denominator, you're going to distribute the 2 through the negative 5x plus 3. You can get negative 10x plus 6, and distribute the 5 through the 2x minus 4 and get 10x minus 20. And to simplify those down, the 12s will cancel in the top. Negative 20x plus 16x is negative 14x. And in the bottom, the 10x's will cancel, and 6 minus 20 is negative 14. So we're left with negative 14x over negative 14. The negative 14's cancel, and you're left with x. So that's the first half of the check. And the second half of the check is f inverse of f of x. So you take the f inverse function, replace those x's, 2 of them, by the original f of x function. So we get negative 5 times f of x, which is 4x plus 3 over 2x plus 5 plus 3. And in the bottom, we get 2 times the original function, 4x plus 3 over 2x plus 5. And the inverse is minus 4. The LCD here is 2x plus 5. So you're going to multiply every part by 2x plus 5. Which just cancels these denominators. And you're left with negative 5 times 4x plus 3, which is negative 20x minus 15. And then you're left with 3 times 2x plus 6, which is 6x plus 15. And in the bottom, distribute the 2 through the 4x plus 3 and get 8x plus 6, and distribute the negative 4 through the 2x plus 5, and you get negative 8x minus 20. And clean things up a little bit. The 15's cancel in the top. Negative 20x plus 6x is negative 14x. The 8x's cancel in the bottom, and 6 minus 20 is negative 14. You're left with negative 14x over negative 14. The 14's will cancel, and you're left with x. So there's the second part of the check. And that's it for today.